My name is Jeff Bowles. I'm the principal of Piccolo Engineering in San Francisco. What follows is a presentation that was given at the Perforce Users Conference in 2003 in Las Vegas. It's also being repeated at a conference in Cambridge, England in late June, so this serves also as practice for that particular conference. The topic is handoffs and software engineering. The reason for putting together this talk is to create a presentation that can be used in isolation to talk about the role of a build or a release engineer to strengthen the engineering process. The title of the talk is Handoffs 101, a survey of expectations that the build engineer encounters. Now, who is a build engineer for the purposes of this presentation? It could be you, it could be me, it could be the guy down the building who didn't want the job. It could be a collection of developers who are sharing the responsibility of compiling and building the product to eventually hand to testing. Who would those developers be? Well, the first night it might be Joe. The next night it might be Jan. And the next night Sue, and then Marge, and then Jack, and then Joe back again. The problem with that last way is that it doesn't provide any continuity. Any mistakes that Joe makes, well, Joe doesn't have to worry about fixing them because he'll be pawning off the problem to Jan and then eventually to Sue. So there's not a lot of time that things will be improved upon. There's not much scaffolding that will happen as a result. That is part of what we're talking about in this presentation, how to avoid those particular traps and mistakes. Now, what is a handoff? Strictly speaking, a handoff is a way of making your work available to somebody else. That's all it is. And there are lots of examples of handoffs. In a software environment, probably the best example might be, I'm handing off software that I've written to a testing engineer. I'll hand it off on the 19th. The question is the test engineer going to be expecting to come in on the 19th, sit down at his or her desk, and start testing immediately? Or do I, as a software developer, expect that I've got up until 5 p.m. or up until midnight on the 19th to continue doing my work, and testing won't really start until the 20th? Little details like that can make or break an engineering process, can make or break the mechanism of making a handoff. A better way of describing it might be to look at a simpler example. Imagine being a 4-year-old who is waiting for a tricycle for Christmas. And his folks go out and they buy a tricycle. And if you've seen, they don't tend to come pre-assembled. They come as a bunch of parts, and you get out your Sears Craftsman tools and put them together. Imagine if the parents don't do that and they hand the kid a box and a bunch of nuts and bolts and pipes and a few wheels and say, here's your present. They bought him a tricycle, but in his eyes he certainly didn't get a tricycle for Christmas. Now, a handoff is an engineering thing. It's an engineering mechanism. It's a way of supporting engineering standards and engineering processes. The build engineer, the release engineer, has the ability to really support that level of organization. The trick is to have only a certain amount of process in place. If you have too much, developers will find that it gets in the way. It becomes busy work, it becomes paperwork and make work. But if you don't have enough, then you might as well have none, because at that point you have no structure. So it's a balancing act. Many engineers in the software industry are used to working at companies that have so much process and so many mechanisms that they truly can't get work done. It doesn't happen. And so when you say the word process to a software developer, they will go ballistic. Process and make work are not interchangeable terms. But since many people believe that they are, implementing process at any company tends to be a bit of an uphill battle. Again, the trick is to do the balancing act. You want to have just enough process. Now, one way to have just the right amount of process is to work on automation. Automate your build scripts. Automate as much as you can from your build scripts. Whenever I am writing a script that will take the source from source management, pull it down into an area on my disk and compile it, package it, and release it to a QA group, one of the very first things the script does is it builds from an identified body of source files. Not things that were compiled and checked in by somebody else, but from source. And it uses a label, or uses a perforce change list number, or uses a time of day on the server, something that is guaranteed to be easily identifiable, corresponds to a specific set of files, and with any luck is immutable, that when you say you're referring to a specific label or a specific change list number, that 6 months from now when you refer to that same label or that same change list number, you're referring to the same revisions of the same files, the same content. So if you see on the slide right now, you'll see an example of the exact command that you would type to populate from a particular perforce label, or perhaps from a particular perforce change list number. Now, in addition to starting from a known body of files, build from a source label, build from a change list number, you want to start from an empty area on disk. By that I mean that the area where you will be doing compiles, where you will be creating and staging the product, needs to be devoid of any file. After that, you bring down files from source management, and now the only things in there are files that you put in there to be compiled. Fresh copies from source management. Then you run your builds. By doing that, you have guaranteed that if somebody wants to recreate exactly your steps, they do it by imitating exactly what you did. They do not have to recreate a process where you have an incremental build where they're recreating steps along the way for every full and incremental build. Recreating incremental builds is just miserable. So always start with an empty area that you will do a full build for anything that is handed across to a customer support group, or across any departmental boundary, or for any handoff. Always a clean build. Now, as you will see from the slides, what I tend to do is I tend to use the source management system to remove its files. Then I use a Unix RM command, a Microsoft Windows delete command, something like that to remove the rest. By doing it in that order, I've guaranteed that the source management system has removed its files and updated its own internal data, its databases, so that it doesn't think I have anything left. Then I remove the local files. That's a nice way of guaranteeing that there will be no surprises at any time. I'm never out of sync with the source management system. It always knows what I have on my disk. In addition, guard against manual steps. Try to automate everything. Anything that is manual requires a human being to be involved. Anything that requires a human being to be involved is eventually going to be fallible. The best engineer, with all the time in the world and all the training in the world, will do a great job. The best engineer, with all the training in the world, who is short on time, may miss a keystroke, may cut a corner. That is not a reflection on the quality of the engineer, that's a reflection on the quality of the process in place. You need to have automated processes to guarantee that things are done consistently. It's important that you try to use the same basic scripts for pretty much all of your compile needs or your release build needs for a particular body of files. If it's the 1.0 code line or the 1.0 branch, that you use a body of files to do the compiles for patches, for overnight builds, for continuous builds, etc. from a similar body of scripts. You don't want to have the code that checks in a log file replicated 5 times if it can be in a subroutine library or in a scripting language that uses objects in some method that all of the compile scripts use at the same time. In other words, use common code for your build scripts. Now, another place to focus is on the handoff contents themselves. The 4-year-old who was expecting the tricycle didn't say explicitly, I want a tricycle, that means 3 wheels, assembled and in working order. He simply said, I want a tricycle for Christmas. But you can bet that he had other things in mind besides getting a box full of parts. You as the person on the sending end, on the giving end, need to verify what the expectations are. Handoffs need to be specified before you even assemble the first one. Who needs what? How do they receive it? On CD-ROM? On tape? On the web? What is the delivery mechanism? What is the content? And what is the other information sent along that will not be delivered to a customer eventually, but that is still useful? For example, if you're handing something to a QA group, you may hand a CD-ROM that is exactly what might be handed to a customer eventually, but you might also hand over a document that says, here's a list of things that are very, very unreliable right now. Clearly, the CD-ROM might be eventually targeted for a customer. The list of what is reliable and unreliable, in its current form, probably would never be sent to a customer. So there will be some things that will be final deliverables, or at least look like final deliverables, and some things that will be internal documents. They are all part of the handoff. Also, it's important to remember to keep the 1.0 scripts with the 1.0 source. If it builds 1.0, if it documents 1.0, it belongs with 1.0. It should be versioned with 1.0. It is not realistic for the 5.0 build scripts to be able to build the 1.0 product. It's even less realistic for the 1.0 build scripts to be expected to build a 5.0 product. Version the build scripts with the corresponding source. This really doesn't just go for build scripts. It goes for documentation, requirements, internal documentation, smoke tests, any kind of testing. So here you have a list of things to go over for any kind of automation. Build from a label, start from an empty area on disk, guard against manual steps, share common code in build scripts, really carefully communicate the contents of the handoff, and negotiate them. It's completely reasonable to go to a QA manager and say, I think you need the list of bugs. Please formally request getting that list as part of the handoff contents. And lastly, version the build scripts with the source itself. Now, if somebody asks you for a report of any kind as a result of a handoff, don't just give them the information. Don't just give them the report. Automate the creation of the report to give it to them the next time. Because if they ask for it once, you want to be able to guarantee that they will never have the need to ask for it again. Automating and automatically delivering that information guarantees they will have what they needed and what they had to actually go out of their way to get the first time, and they will automatically have it next time. On the slide, we'll see a couple of ways that you can do this. One way that you might do this in any system is just simply have a label that is the previous handoff and a label that's the current handoff, and just simply compare the two and give the output that is basically the comparison of the two. Always useful to do information like that. Now, another thing to remember is that different groups who are downstream of you have different needs. A testing group needs to know what's changed, and they need to know the results of any compiling, any error messages in the compile, and the results of any smoke test. You will remember that a smoke test is when you would, or in the olden days with a board, you would plug in a board and see if it smoked. But in the case of software, it's basically a minimal functionality, very fast test. The testing manager is going to want to know, does it even pass the basic test? Because those smoke tests very often tend to be acceptance tests to know whether to even start testing. That's a testing group. A tech support group may have a different need. A tech support group needs to know how to support the product. They need to know what's flaky, what they're probably going to get telephone calls on. They need to know what's been reworked. They need to know what's been changed. But they have a different view. They will be the experts talking to the customers. They need to know different kinds of information. A documentation group is going to need to know, what does the product look like? They will need an early view of the product in order to be able to make plans for documentation. They will need a much later view to be able to start writing documentation. Hopefully, one of the handoffs to the documentation group might even be, before the product is started, early versions of requirements documents, so that they can start anticipating what they will need, what kinds of documents will support this. The documentation groups have different needs also. The rule of thumb, just like Christmas gift giving, ask what they want, give them more than you think they need. Now, looking at the slide, which would be more useful to you if you were a testing manager? a list of bugs fixed, or a list of bugs fixed that includes with each bug number some ASCII text that says what the bug was? The answer to that's really pretty obvious. The one that has more information. This is a case where, in making the list that had the bug numbers, there was nothing that kept you from including a little more information, namely the text. By doing that, you have created a lot more useful report or a lot more useful handoff to the person who's receiving it. Yes, they have access to the source management system. Yes, they have access to the bug database. Yes, they can go get that information themselves. But you are at the well already. Save them the trip. Any testing engineer who gets that second list, bug number and text that says what they are, will eventually probably run that same report that you ran to verify that it is an honest list. But once they start realizing this was generated by the automatic build and delivery mechanisms, they will relax and start simply looking for that as part of the handoff. It's completely reasonable that they do that because you are providing it automatically. What you're doing is you're making it possible for them to start working the instant they receive the handoff, instead of having to do an extra amount of work before they start. Again, save downstream groups trips to the well. Now, one question that any QA manager will ask is, you're delivering me a patch. What was recompiled? And if the answer that comes back is, well, we only changed 2 files, but everything got recompiled because we made a new patch branch, many QA managers are going to look at you and say, alrighty then, I guess we regress everything. And what was supposed to be a 2-day testing cycle simply became a 2-month full regression, completely destroying the schedule for the patch. That's not a case of the testing manager not doing his or her job. In fact, that is an example of the testing manager doing exactly that, doing their job. How do you avoid the situation? By anticipating the situation, by seeing it coming. One thing I often do is I will make the patch code line before the release itself goes out. I will make it, I will build from it, and the first patch built out of that line is actually the final release delivered to QA. So that the first real patch that is post-release, well, that's a minimal delta. That way I've gotten the headache of regressing the full, newly compiled stuff out of the patch line out of the way a long time ago. It was out of the way as part of the release process. How do you do it? By being lazy. By using as much of the QA cycle to test not just the product, but the product and the support and testing the ability to issue a patch. So, there are a lot of ways to anticipate these kinds of questions, but you need to ask those questions long before they come up. It's where the interesting part of the job is. This is the type of role that works very well when you are spending your time anticipating a problem that comes up 6 months from now, 8 months from now, and solving it now. This is an example. Very often you will have a situation where you will get one of a certain number of answers or responses to a situation. Unreasonable responses, but still believable responses. One, for example, might be, we can't build this automatically. That is guaranteed to be a false statement. Anything can be built automatically. The question is, how much work are you willing to go through to do it? You never want to take something that was compiled by somebody else and include it into your own product, unless that somebody else is a third party that went through their own testing process and released it externally to you. In other words, including the Microsoft DLL for a particular purpose that was built by Microsoft, tested by Microsoft, released by Microsoft, and handed to you, and where you are simply repackaging or re-editing or reissuing it. That's okay. But taking something that Joe developer compiled on his machine and just simply checked in so you could include in the release, no, you never want to do that. All you have to do is spend just a little bit of time thinking about the security implications of such a thing, and you realize how unworkable such a challenge is. So, everything must be built, and to guarantee consistency, it must be built automatically. If somebody says, it's not my job to do thus and such, the job of a build and release engineer is not really to sweep up after everybody else, but it tends often to be such. And that is the one job in the entire software engineering industry where you can say, you know, my job is to help move things along the pipeline of software development. I'll help. I'll make sure that this handoff is clean. And the easiest way to make sure that things happen like that, it's communication. Just making sure that people know what it is that they need to know to do their work. Somebody might say, hey, it's in the bug database, it's in the Perforce database, it's in the source management database. They can look it up. We've gone over that already. If you have any ability to save another group a trip to the well so that they do not have to go and collect information or write reports, if you can do it, if you can help a downstream group, always do. A last one on that line is somebody might say, I can't include the release notes, they're not final yet. I can't include this documentation, it's not final. I can't include this particular module, it's not final. Many times a release is put together using last release notes, using the last release's version of this module. And then they will just have those in as placeholders. And once the final version is ready, then they will swap the placeholder for the real version. So you do not have to have the final version of something to have a placeholder to start with. In the software programming tool chest that a build engineer uses, it's important to have some scripting language available to you. When I say scripting language, I mean something that is an interpreted language that allows you to do pretty high-level, powerful tasks, and that also allows for you to change and reiterate and try again very quickly. Perl is a scripting language. Java is not. Python is a scripting language. C is not. Good examples of scripting languages might be the Unix shell, which you will find on any Microsoft Windows environment that I'm on by looking for the MKS toolkit or the Cygwin toolkit. Perl is a scripting language, Python, Ruby, all very good languages. The reason why I say that Java is not, even though it is an interpreted language, because what you have to have installed in order to be able to really use Java sometimes is not just Java, but Java plus the EJBs, and Java plus this and Java plus that. It's not realistic in terms of fast, iterative changes to your scripts. So I would not go with Java for any build system for that reason. Script the build. Script the build, script the handoff, script the delivery, script everything you can. Another, make your initial build notes. How do I compile this? How do I build it? Make your initial build notes in the form of a script. I need to compile this, now I need to compile this, now I need to copy this here, now I need to compile this. If those notes are written in that way, it's not very long before you can transfer them into a shell script, a Perl script, a Python script, a Ruby script that actually does it and becomes the first passage of build script that is automated. Also, get agreement on handoffs. In the same way that the 4-year-old wants the tricycle that is fully assembled with a certain number of wheels, etc., or the testing engineer wants a product to be delivered and ready to test at noon on the 19th. You want to make sure that you have agreement on handoffs, and the key there is very clear communication, and do it in writing. And try to imitate exactly the same handoff the next time and the next time and the next time. That's the argument for automating the handoffs, so that whatever you've agreed to will stay in place until it's modified. The last one is, notice other people's work. Notice people's work. Notice people whose work you can encourage. Notice people whose work you can use directly. There's an economy of scale when all of the people who are doing build work at a company do it in the same way, even though they're not in the same departments. Encourage people to use your work, but also use other people's. Leverage off others. Do not reinvent work if you can avoid it. Again, the real thrust here is pay attention to the inputs of an organization and the outputs of an organization. The job of a build engineer is to take requirements, source code, and various different mutterings about what we'd like to see in a handoff and turn them into outputs that are very useful deliverables to a testing group, to a support group, to a marketing group, to a documentation group. Focus on the inputs and the outputs. That's the handoffs. Everything else comes into line.